Hello everyone, welcome to MathSci Easy. Here's another question type that you get in A-level physics. It's a quite interesting question, and I've seen that some students struggle with this type of questions. So the question is on the board. Lamps A, B and C are identical, meaning they have the same resistance and everything. The filament in lamp B melts, so there's no more conduction through lamp B. Explain what happens to the brightness of lamps A and C. So I want you to pause the video and give it a try. Come up with as much details as you can and explain the reasoning as to what happens and why. And I will explain the answer in a minute. Pause the video and try it now. Okay. Now, when lamp B melts, so technically there is this branch does not exist. So I can just completely get rid of that. So there is this branch does not exist. So what will happen? Current will simply go through this, go like that, through this one, and like that. That's what happens. But what happened earlier? Earlier, current went like that, through this, and split up, because these are identical half, and then went like that, and went like that, and back to here. Now that's the difference between the two circuits. Now let's use this to explain what really happens to the brightness of lamps A and C. Now, another really important thing that you need to understand is whenever they are talking about brightness, you need to think about power, because the power is what determines how bright a bulb is. Now, let's assume that the voltage of this is V, right? This is the EMF supplied to the circuit. Now, in the second circuit, obviously, this is half of V, this is the other half. Why? Because there are only two identical bulbs now, so it will be V over 2, V over 2. What about this one? Now here, if you think about the resistance, now if this resistor is R, this is R, this one is also R, so the overall resistance of these two is what? The total resistance here of this combination is half of each, R over 2. I've mentioned this earlier. When you have two identical resistors connected in parallel or even more than that, if they are identical, you divide the resistance of one by the number of resistors, so you know the total resistance, in this case R over 2. Now, you can see the ratio of resistance is 1:2, R over 2 and R. Oh, so because V is equal to IR, right, and the voltage will split such that it is proportional to the resistance. So the voltage across this one is 2/3 of V. The voltage across the other combination is 1/3 of V. So that it's in the ratio 1:2. Now, we can use this information to decide what happened to the brightness of lamp A and C. Now, let's just think about each lamp. Lamp A and lamp B. Now, lamp A had a potential difference of 1/3 of V earlier, and now it has half of V. Oh, so that means the potential difference across lamp A has increased. Now remember, power is equal to V squared over R. Now all of these resistors have the same bulbs have the same resistance, so R is a constant. So the power is directly proportional to V squared. Okay, so whatever happens to the voltage is what you see in power. Now, as you can see in the yellow highlighted region, earlier lamp A had a voltage of 1/3. Now it has increased to half. So definitely lamp A becomes brighter, right? As the voltage increases. Now I've already indicated it here 1/3 and half. I can include it like lamp A becomes brighter as the voltage increases from 1/3 V to half V. But I've mentioned it here, so this is enough. What about lamp B? Lamp B previously had 66% of or 2/3 more precisely 2/3 of the voltage, but now it has only 50%, half of it. So what will happen to lamp C? Lamp C will become dimmer, right? Lamp C, sorry, I should change this. This is not B, this is C. Yeah, I'm going to change it. Lamp C becomes dimmer as the voltage decreases. Now, this is one way of doing it. You can also think about the current. You can get an expression for current and you can work it out the same way, because the total resistance of the two circuits are different. Then the current will change. Then you can use P equals I squared R and you can evaluate it the same way. But I think this is probably a little bit easier than that. But either way, you get the same answer. So the answer is lamp A becomes brighter because the voltage goes up. Lamp C becomes dimmer because the voltage decreases.